you guys are doing. So
Yes.
it will take some time. No issues in there.
In
But are you
Ansible part, there
feeling
is no questions.
okay? But are you feeling like a little bit comfortable on like the Jenkins part, the way that how you have worked on so far?
Yes, so much. Like we got a little bit of confident on Jenkins now.
Perfect, perfect, perfect. We will be again doing the integration. I hope everyone understands that we have what Docker and Kubernetes topic, and then we have a Terraform. Terraform is a different thing, but Docker and Kubernetes when we will be doing right. So again, we will be touch
Mm.
basing on the Jenkins part, like how the CI/CD works with Docker, how the CI/CD works with Kubernetes. So we will do that kind of connectivity there.
Got it. Thank you so much.
Great, wonderful. So if everyone is good, so let's get started. First thing first, resources. Presentations which we will be using. Docker Kubernetes is primary one, but I'm also giving one OpenShift one, which is just for your learning, right? For your learning understanding, because OpenShift, Red Hat OpenShift is a custom like an enterprise version of Kubernetes. So when you go for that, you will be able to like really see like what is the main difference. Although it's not a part of the topic, but I'm just sharing that content with you. There are just 7 to 8 slides only there for you guys to understand and grab the knowledge. So I'm just sharing the documentation here. The same I'm going to do it up in a group also now itself. Great. So let's get started. With the Docker. Now, before we begin with this particular topic here, so I really wanted to understand from you guys, what's your definition about Docker? Like when someone says Docker, so what exactly it comes into your mind?
Container,
Virtualized environment.
Mhm.
microservice.
Okay, yep.
So basically, it solves problem. It works on my machine. It's not working on other machine.
Mhm.
The problem it's solving.
It allows us to ship packages or artifacts consistently from dev environment to other environments.
Okay, that's great. Anyone else? Okay, great, wonderful. So all the responses were correct. and it was fantastic. Now, when we talk about the like the tool over here, which is like uh, the implementations. So we are definitely going to see like how exactly these kind of options are going to be working, because when it comes to the setup, like when we are talking about the application placement, we have seen Ansible also, right? Now what we were doing in the Ansible is like we were getting it up the code deployed in the virtual machine. So that's why before Docker I always work and explain the Ansible. Now in Ansible what we are doing, we are writing up certain codes and certain implementations, because again using that we would be able to see like how the mechanisms are going to be rolled here. Just give me 2 minutes, huh? Okay, I'm so sorry. So yes, so all your responses which you like rightly shared, they were all like correct. Definitely, that's the real purpose, like why you need to go for the desired tool and the implementation here. But I'm going to use some couple of diagrams and some couple of images for us to understand that why um, exactly we need to go for the Docker, because it's not like it's kind of a trend. Sometimes it's all really about a trend also, that since it's a new tool, so everyone is like kind of going out and trying to implement it. But in some cases, we also have a scenario where we see like how these executions are going to be driven. So let's talk about those concepts over here, and then we'll see like how it works. But before we even go ahead with the Docker, we also need to talk about one terminology, which is called as in microservices. And microservices is one of the most modern architecture which we have in the industry, in the market at this moment of time. Because when we talk about the microservices architecture, so we need to understand that how this architecture is really going to work. The whole point of this architecture is that when we are going to work on this, so we actually migrated from a legacy architecture. So there was a legacy architecture which we used to see, we used to follow on those kind of an uh, implementations over here, right? So what is the difference? Let me show you the difference. First, I'll talk about the architecture here, like from the image, and then we will see like how this thing works here. Now, the diagram which you see over here in front of you is a clear comparison between uh, the monolithic architecture and the microservice architecture over here in this one. Now, what exactly we are going to get in this architecture here? So what is a monolithic architecture? So monolithic architecture is a kind of an architecture. It's a component in which we are going to talk about the understanding on how exactly we can go and we can make our structure. We are going to make our component, because when we are talking about the legacy architecture or the legacy project, so they work in that particular domain. So how they really work, so you will, I mean, some of you guys might have seen this kind of an architecture very commonly there present in the market, in the industry, that you would have a database, and you have a data interface for that, then you have a business layer, then you have a user interface there. So they are like combined together as a kind of an three-tier architecture. And this three-tier architecture is something where they are bundled up together, like a combined together as a single component. So if let's say there is a small change, like even if it's a small GUI interface change or modifications which you have to do, so in that case, essentially, you would have to go ahead and do a complete end-to-end implementation. It would really go ahead and have a kind of complete end-to-end setups done here in this one. So monolithic architecture is something which is definitely going to be a problematic situation, like a problematic component, and it's definitely going to see like how this thing goes here. And when you talk about the microservices architecture, so microservice architecture, if you see, it's nothing but a transition from the monolithic architecture. So what kind of a transition we are talking about? So the kind of the level of transition which we are talking about is like how a big giant application we can go and we can split it out into a small microservices. Now, of course, it's going to be a giant activity, like a giant process from a development perspective, because as a developer, you will have to really go ahead and drive this activity. There is a total rewrite which you have to do, most probably in this particular case, in this particular scenario. But there are unlimited benefits which you will be able to get with this approach. Let's talk about this one. Now, what are the disadvantages of a monolithic architecture? Because definitely if someone have gone to a microservice architecture, so something was wrong. Something was not working, like as expected. And, that's the whole reason why we are like getting this new architecture right on this one. So what was, actually failing? So let's talk about that. So when you talk about the monolithic architecture, right? So we really need to understand that how the things are going to be transformed, like how we will be taking care of that particular changes. Because when we talk about the scenarios, right? So in this one, we really have a lot of components there, a lot of viewpoints, a lot of sections which is going to be present. Hmm. So when we do, or when we talk about the monolithic architecture, so we are definitely going to talk about like how this structure is going to work. Now, monolithic architecture, if you see closely, it's a so bulky architecture, so bulky component is there that if you really want to go and modify or customize any kind of an thing or any kind of a small component also, so you will essentially be able to go and like redeploy the whole application there. Total redeployment of an application is going to be done. So it was a huge mess because if I really don't want to like redeploy the whole product just for a small change, so it was practically impossible for you to do that. But if you see microservices, we are already saying that we have split up the big application into a small microservices. It's a small microservices which we have got over here. So when we have got these different microservices up and running, if you want to deploy any of these, you can easily go and you can do so. Why? Because in this one, you don't have any kind of a single application. There are multiple applications which is really involved over here. And these all different applications you can deploy, you can restart, you can upgrade, you can, like do a new code deployment. So all that stuff you can go and you can perform it up over here in this one. That's one of the biggest advantage, because I have worked on the monolithic architecture and I have seen that people are going out and deploying the whole big bulky application. It's taking like 2 hours, it's taking like 3 hours for getting the code deployed. A lot of steps are there. So definitely that's not a kind of a good process. But of course, at the at that time we were not having any kind of an alternative, so we were just kind of and going up with this process only, and this is the only like options which we will be following, and we will be getting up here. So definitely that's the whole process which we will be following, and we will be generating those kind of viewpoints there. So that's the main aspect. Second thing is that if you need to develop any monolithic application, unfortunately, you have to design the UI interface, backend, database interface, or any kind of in business logic in the same programming language. So let's say if you're sticking up with the Java, so you will have to design the whole application in Java only. But what is the problem? I don't see any problem. So there is no problem in using the same programming language. Good, it's comfortable for the developers. But in a longer run, it's not. Why? The reason behind that is very simple. When you go with the monolithic architecture, so there we understand that we have a foundations on the programming language, which means you have to stick to a single programming language. But if I talk about Java, I know like I cannot create a futuristic design like a UI interface in the like a Java programming language. So what we can do in such case, what we can perform in such scenario? So definitely that's an important part which we need to consider, and we need to see like how these implementations are going to be done here. So microservices give us an architecture where we can deploy these microservices in different programming language. If you feel comfortable that the UI interface can be designed in a kind of an AngularJS programming language, go for that. Backend you can deploy in the like kind of this thing in the Java, .NET, these kind of programming languages. Right. So definitely that's the whole point, and that's the way that how the things are going to be like transformed, and we can take care of those kind of like scenarios here. Right. Perfect. Now the another benefit which we have over here is that if we do any kind of a restart of any one application, so that's something which is possible with the microservices. That if I just want to go for restart only for only one service alone, we can easily go and we can do so. This is the advantage. This is the benefit which we will be able to get it up with the microservices architecture here. Right. So this is the one of the reason. Now here, of course, you might be asking that why we are talking about this. What is the role of this concept in case of Docker? It's very important because of the fact that here in this one, uh, because in this one, what we will be, like, what we will be performing is like we need to understand that how the things are going to be, like setups and how we will be performing those details. Because, like, again, microservices and containerization is not connected with each other. That's for sure, right? It's not like that, but it's still, something which is very important, and we can see like how this thing goes on there.
And sorry to interrupt. If you're sharing any other screen, it's not visible.
We're not able to see the microservice architecture.
Microsoft architecture we can able to see. No,
Mhm.
if you're explaining any other screen, it's not visible.
No, the screen is not stuck. So this is the same thing which I'm
Okay.
talking about. So I mean, this is the same advantages and disadvantages I was talking about, right? So that's like something which is, like available. Right? Okay, that's it. One second. Just 1 second. Just give me 2 minutes, guys. There is some network issue. 1 second.
Okay.
Can you hear me guys now?
Yes, we can hear you.
Okay, okay. I'm so
Yes,
sorry.
Anush, we can hear
I'm
you.
going. I'm so sorry there. I'm so sorry. Okay, great. So yes, so what I was talking about is a microservices architecture. Now I totally agree that as a developers, we would be like more involved on this, and as a DevOps engineers, we will not be involved much on this particular part. But still, what happens is that this is very important because consider this as a kind of in step one in the whole process of implementing Docker, going for the containerization. Consider this as a step one. Now, is it like a mandatory thing to go for microservices? No. There are some integrations, there are some migrations which I have myself done where they have not done the microservices because the efforts to put up a monolithic application to microservices was very huge. So they want to run this on a containers for just 1 or 2 years, and then they want to like see that if it's beneficial, then only they will go for the microservices architecture or like splitting up the applications. So that's where like this really comes in, and we need to see like how this is going to be transformed or it's going to be working here. So microservices have its own benefits, not necessarily that you have to implement containerization, but consider this as a kind of in step one. So if now today you have to go or talk about to an like a application that whether we want to go for the migration or not. So definitely that's where like microservices is going to be considered as like step one here, right? So you get a freedom to deploy it up anytime. If there is any issue in microservices, the whole application will not be down. You can deploy any kind of an microservice with any programming language, so you don't have to really go and deploy all the applications together. If there is any kind of an slowness is there, so only that service is going to have the slowness, not the whole application. So these are some of the advantages or the benefits which we will be able to get here, right? So that's the like the options. Now what is the disadvantages? Disadvantages is there. I totally agree because see this one, you were having one application, you were having one application logs, but the moment you migrated to microservices, suddenly you're getting like five applications, five different application logs. You will require to do the debugging. We are already talking about that in microservices, you have full freedom on what programming language you want to use. So if let's say five different microservices designed and developed in five different programming language, it's going to be a disaster. Why it's going to be a disaster? Because of the fact that you are going to develop them into a different programming language, and like you will require a different expertise. Different individuals will go ahead and check the logs in differently. So there are a lot of use case, there are a lot of differences which is really going to be present here. So definitely that's going to be a problematic situation and a problematic part here. So we really need to understand that how exactly the monolithic and microservices architectures is really going to work. So as we can understand that how the things are going to be rolled out, and we can take care of those kind of an options here. Right now, if you see in front of you, is it just a basic architecture which is available there? Right now, when we are, like going to talk about these kind of changes. Now, because when we are talking about these particular microservices, because here you can see closely that there are some microservices connected with each other, right? So we have the connection, and we have like some of the microservices being connected with each other, and they are like a kind of connection on there. So it's still there, and it's definitely going to be, communicating. Some of them are like directly connecting to the UI. Some of them are like kind of an intercommunicated with each other, and we can see. with how these kind of options we will be following, and we can take it out over here. So definitely that's the important part we will be following. Right, so that's the options which we will be following. Right, so this kind of diagram or the architecture is something which is going to be making sure over here. Right, now again, there are certain reasons. Now we talked about the like the component over here, because what happens is that when we are talking about the microservices, that's like I said, that it's going to be a like a stage one, like a step one, right? That's one thing which we have over here. But there are certain other like tools which is there. You want to use the JBoss, you want to use IBM, WebSphere, Tomcat, Apache. There are so many tools there. Because after microservice architecture, you can choose any tool for getting your application deployed. But the question arises that why we are going for containerization? Why you and me, we are talking about Docker? There must be something different in this one, which really like promoting or like giving the developers an edge to go ahead and have the applications deployed. So there are like a lot of reasons behind that. It's not look only talking about one region or two region or three regions. There are like, I would say, 3 to 4 good and heavy duty regions are there. The very first region which is there in front of you is talking about very core issues. Now, some of you guys might have also seen that sometimes it happens that the same piece of code base which you have built out, it works on the developer machines. Sometimes it works on the QA professional teams, but in a production environment, in the live environment, it's not working. Like you are facing some issues, you are facing some problem in there. It's a very common thing which happens in the market, in the industry. So, I mean, of course, you need to make sure that everything, any kind of an code base is there that can run on any system. That's the ideal way. I cannot say that it's going to run on an Android and it's not going to run on iOS. That's not the justification. So it should run anywhere, wherever I want to run it. So what we need to do in that case, in that scenario, of course, the organizations are trying to do their best to make sure that the application which they are deploying should work on any platform or almost every platform. But again, in this case, we have to understand the scenario, like how the things are going to be transformed. And then according to that, the overall setups and the mechanisms is going to be generated here. So we have to take care of those kind of, like an options. So how we will be transforming it, like how we will be taking care of that options. So for this one, what we have to do is, like, there is a problem statement which we will be following, which we will be conducting here. So how exactly it works is, like, when we talk about the this problem statement, the versioning problem. So what here we are going to do is, like, of course, I'm going to do some builds into my local system, into my dev machines, and then we are going to see that kind of the options over there, right? So we have to essentially perform. But usually what happens, that there are some mismatch in the versionings. For example, I have deployed certain Java version into my local system. But when we are deploying that into my production environment, we have got a different thing. We have got a different process there. So definitely in that case, in that scenario, what we need to do is like we need to see that on how we can go and we can resolve this versioning problem. And for that part, we should be fixing, the way that how we are hosting our applications. I might be having like a Java 21.7 version, but in production you are having like 21.15 version. Usually in the minor versions, you don't see like a big impact, but sometimes it happens that you have a two different versions in two different environment, and that compromises the system. And I have seen this problem very like like very, very frequently there. And most of the time it fails. Then, the development team is debugging. They are like trying to fix it. They are trying to analyze that what went wrong. But we cannot do anything about that. We cannot perform anything on such kind of things. So in such scenario, in such cases, Docker is saying that I have a solution. I'm going to give you the solution and the options, because in this case, what we are going to essentially do is like Docker is saying that I will give you a mechanism where we are going to package everything together, like the base image, the runtime, the Tomcat Apache or whatever the tool you wish like you want to install. We're going to have everything together. So you can see like one container is this one, like which we are going to do and we are going to deploy. And the second one is like another container which is going to have here. And the third container where we have the Alpine and the library, the static binary going to be present. So this way we will be able to really see like how the implementations is going to be done. And then according to that, we are going to get those kind of functionalities and the tools here. So this is a basic approach, like a quick way that on how the things are going to be, like managed and we are going to be maintained here. So that's the real purpose of using this one. So Docker is saying that you don't have to worry about the binders mismatch, because I will be giving you an alternative where you can package everything together as a single bundle, and then just simply go ahead with that part with the deployment. So this is one of the problem statement which is being followed, which is being resolved by the Dockers with the containerization. Second one is about the basic architecture. Now, when you talk about virtual machines, you allocate, let's say 30 GB, 40 GB, 30 GB, 40 GB, whatever the resources you allocate to a virtual machine. It's a hard code allocation. When I say hard code allocation, it means like whatever the resources you have allocated, right? So in this case, if let's say I'm not using any kind of a resource, like for example, in case of virtual machine one, if we are not using any kind of a resource, that's going to be considered as resource wasted. We are not like using that resource as such. If you're using it, that's fine. Otherwise, it's going to be a kind of an unwanted resources, right? So we will not be able to consume it. We will not be able to utilize it up in anyhow. Right? So that's why people don't prefer like for application deployment as a virtual machines, because here the wastage of resources is high and you will be essentially facing a lot of difficulty and a lot of options. So in this one, in case of virtual machines, what happens, like we have, let's say memory wastage is 20, memory used is like 80 GB. So we have that consumptions, we have that, utilizations, which we will be able to see like how the things are going to be transformed. Right now, the same thing we have a Docker also. Now, what is Docker? So in Docker, we are saying that, okay, first of all, I will not take that many resources like a virtual machine. That's one of the aspect. So Docker containers is something we call it out as a lightweight. They're not going to take that much resources like a virtual machine. Second, when we allocating, like these, like these different kind of an options which is available there. So when we are talking about the Docker containers, because in this one, what happens that if we are not using any kind of any kind of an resources or any kind of an implementation. So because again, what happens that in case of like a Docker, so first you like having less resources utilization, right? And second thing is that the resources which you allocate, right? Let's say you are saying that we are going to allocate 30 GB. So out of that, if we are like using 10 GB, so rest of the resources is still there. Of course, I have the possibility that I can go and I can utilize those resources, but it's not called as in resources wasted. It's like something which we will be, going up and we will be following up so that we are having the unwanted resources used by some other containers, or maybe like you can use it out for your own purpose, but it's not something which we can call it out as a memory wasted there or any kind of a resource wastage. That's the biggest advantage. That's a primary advantage or benefit which we are going to receive over here, because it's really going to help us to see like how the things are going to be transformed. Right? So this is the reason second that when you talk about containers, they take less resources. Plus on top of that, whatever resources not used by containers that can be used by you. So you don't have to really go ahead and call it out as a resources wastage, because you can go and you can consume it and you can work it up on that one. So that's something which is very, very crucial. Right? And what is the third reason? So the third reason over here is the architecture, the way that how the containers work, because I'm already talking about that the containers are lightweight in nature. What is the reason behind that? The reason behind that is very simple. Like when you talk about the virtual machines and the Docker, like the comparison. So here in case of the Docker here. So what really happens is like we are going to talk about how the things are going to be rolled. So in case of a Docker, so we do have like, for example, when we are talking about the a Docker here. So here we don't have that kind of an high end or like a heavy duty guest OS, just like we have in case of the virtual machine. So we don't have that part. We don't have that kind of an setup here. So in case of virtual machines, we are like working up, or it's like a heavy duty work which is available there. So that's not the same scenario which is going to be present in case of the Docker. So in case of virtual machine, you have a very high end, like a heavy duty, operating system which is available, but that's not the same case in in the particular Docker. So Docker is having very lightweight OS layer, which really helps in, because the overall utilization will be small. The size of the container is also small, and the boot up time. So the boot up time is also impacted, because when you have a small lightweight containers, they're not going to take too much of time to start up to boot. This is the reason why Docker is preferable, because if you see all the three options here, they are like potentially resolving certain problems. I'm not saying that you're following a trend. That's why I have chosen these three images, because here I'm actually like proposing to you that why the organizations and people are like going for this particular tool, like why they are preferring that. This is a kind of an a better tool available there, because it enhances the way that how the things are going to be routed. Right? So that's the the options which we will be having over here in this particular case here. So tomorrow I'll talk about with you guys like how exactly this thing works, and we'll see how this utility functions, and we can talk about that. Okay, so let's work on tomorrow.